Hello everyone, welcome to my channel Chemistry by ANR. This is the revision series for the electrochemistry chapter where I have given in a gist, I have given in a nutshell the formulas and the concepts. The first thing is R is equal to rho into L by A, where we can see this is the formula of resistance with respect to resistivity. Resistivity is rho, resistance is R. So R is equal to rho into L by A, and L by A is the cell constant. If L is equal to 1 centimeter and A is equal to unity, that means 1 centimeter square, then R is equal to rho. That is how you can define resistivity. Now, next we go to kappa. Kappa is equal to 1 by R into cell constant. We know cell constant is equal to L by A. Now the question arises, what is kappa? Kappa is the conductivity or the specific conductance. Now what is specific conductance? It is the conductance of a solution of 1 centimeter length, you are assuming it, with 1 centimeter square area of cross section. So that is kappa. And L by A is the cell constant that can be given by G star. And conductance is 1 by R, that is G. So you can write G into, that is kappa is equal to G into L by A. So what is conductance now? Specific conductance you have seen. So what is conductance? It is the ease with which electric current flows through the conductor. That is conductance, or G. Now kappa is also equal to 1 by rho, which is rho is resistivity. So it is the reciprocal of resistivity. Next, molar conductivity lambda m is equal to kappa into 1000 by C. So conductivity into 1000 by the molar concentration of the solution. That is molar conductivity. And here is the theoretical way how you can define it. It is the conducting power of all the ions produced by dissolving 1 gram mole of an electrolyte placed between two large electrode, which is 1 centimeter apart. Next is lambda m. We know it is equal to kappa into V. Why V? Because it is the volume of the solution in centimeter cube. And in most of the numericals you use this formula. Lambda m is equal to kappa into 1000 by C. And this you have NCERT exercise questions, exemplar questions where application of this particular numerical is there. Now, SI units of these, I will say the factors are what? Rho. Rho is equal to, we know what are they? So rho is resistivity. So that is ohm meter. G is Simon or S, and Simon means ohm inverse or mho. These are the SI units. Kappa has SI unit of S per meter or S meter inverse. Lambda m has S meter square per mole. And the CGS unit, you know, in place of the meter, that will be the centimeter. Now, next we have kappa is equal to 1 by R into L by A. The value of R of the solution between two parallel electrode is determined. Okay. How? Using Wheatstone bridge. How? Using Wheatstone bridge. I think this you have seen in the physics also, how to use Wheatstone bridge and find the resistance, that means unknown resistance that has been seen. Wheatstone bridge. I think you remember the formula, all of you. R1 by R2 is equal to R3 by R4, where if you take R2 as the unknown resistance, say this is my unknown resistance, and then you will calculate R2 using R1 into R4 by R3. If you try to recall how to do this, you will see this is the Wheatstone bridge where a conductivity cell is being taken. So this is your conductivity cell. Say this is your conductivity cell, and your connection is like this. If I say this, here is your R2, that is the unknown resistance, and this is the arrangement, how you connect it. Okay, so here this is one R1, I will say this is R1, and here if I say this part is R3, you can see here there is a series connection between R4, R3, parallel connection between the other. So what is it? This is the detector again. I can use. Here is the detector. So this is the detector, and this is your Wheatstone bridge, and this is the switch. So if I say this is the setup, so from here R2 is unknown resistance and rest are known to you. So you can find using the formula of the Wheatstone bridge. Now, lambda m naught is the molar conductivity at infinite dilution. So at infinite dilution, where the concentration or molar concentration of the solution tends to 0. At this stage, we can say by using Kohlrausch law, we can say that lambda m naught is equal to x into lambda m naught of a raised to the power y plus. What are they? That is, they are the individual contributing molar conductivities of the cations and anions and a summation of them. This is an application, or rather this is the representation of the Kohlrausch law. Next we can say, what is alpha? Alpha over here is equal to the ratio of lambda mc. Lambda mc means molar conductivity at a given concentration by molar conductivity at infinite dilution, where alpha is equal to the degree of dissociation. This is degree of dissociation, alpha. Now, for a weak binary electrolyte, say AB is a weak binary electrolyte, we can say kappa is equal to C into alpha square by 1 minus alpha, and this is also used in numericals. So these are used in numericals. E naught cell, to find, we use E naught cathode minus E naught anode, which is E naught right hand side minus E naught left hand side. So this is a revision. You are not doing elaborately. So for seeing the elaboration, you need to follow the other videos in the playlist. Now, Nernst equation for general electrode reaction. If I say this is one electrode reaction, what has happened here? Gain of electron. So we know oil rig, oxidation is loss of electron and reduction is gain of electron. So here gain of electron has taken place, and so what has taken place is reduction. So EMN plus to M is equal to, that is reduction potential. This is the Nernst equation for the general electrode reaction. E naught cell, that is E naught Mn plus slash M minus RT by NF. Now here ln is there. To remove ln, to form it to log, multiply it by 2.303. And what is this? It is coming, if you multiply R and you multiply the temperature 298 Kelvin and use divided by F, that is Faraday constant, you will get 0.059 by N log of this. 1 is taken because this is the solid form M. Now, Nernst equation for the general electrochemical reaction. This is one general electrochemical reaction where we are using it. We are seeing this is product by reactant. Molar concentration. Now, log Kc, Kc is equilibrium constant, is equal to N by 0.0591 into E naught cell. This is also used in order to find the equilibrium constant, or in order to find the unknown in the equation. So delta G naught is the change in the standard, Gibbs free energy, that is equal to minus NF E naught cell. Again, you place the values and then you will get into this again. Minus 2.303 RT log Kc is another equation. So what I want to say is you can use this wherever required, or you can use this also wherever required. Okay. So next, Faraday's laws also are there. So here you can see Q is equal to I into T, where Q is the quantity of the charge in coulomb, and I is current in ampere, and T is time for which this current is passed in second. Now W is equal to ZIT. This also you have seen in the Faraday's law, where W or M, it is represented by M also in some of the books. You will see it is mass of substance deposited at electrode, and Z is your electrochemical equivalent. To find Z, you have various methods, and this is one method which I have shown you, molar mass method. Theoretical formula, E by F is Z. E is your equivalent weight, which can be given by molar mass divided by the valency or number of electrons exchange, and F is Faraday constant, that is 96500 coulomb per mole. So Z is equal to M by NF. This was one example where I have shown you how to find Z using this particular formula for silver. Ag plus gaining 1 electron. So this is the quick revision of electrochemistry. Hope so it was useful.